Hello everyone, welcome to the second video on probability distribution. So in previous video we had seen prerequisites thing, and so in this video we have to see, we will define probability distribution. What do we mean by probability distribution? So in this video we will see what is probability distribution. Okay, so to understand this concept, I will take a example, then we will see what is probability distribution and how it looks. Okay, so example here I am taking is tossing a coin 3 times. So here the random experiment is tossing a coin 3 times. Okay, so I have a coin and I'm going to toss it 3 times. So let's see what will be the outcomes on those 3 tosses. Okay, so if I toss first time, I don't know what will be the outcome, so let me write tail. Then I have to go for second toss, so let's say again tail, then I have to toss it last time, say head. So this is one possible outcome. So tail, tail, head. So how I'm going to read this? On first toss I have a tail, second I got a tail, and on third toss I got head. So I want to count the total possible outcomes like this. So I cannot keep writing all the possible combinations of T, H, H, T. Okay, so let's have a tree diagram for that to write the all possible outcomes. So here I have a coin, and this is my first toss. So the outcomes are either head or tail. Then this is my second toss. So irrespective of head or tail, I have to go for second toss. So on second toss, on every branch I am going to get either head or tail. And last is my third toss. So head, tail, head or tail. So this tree is going to give me my total outcome. So how to write? H, H, H. So I'm going to make the combinations of 3. So this H, H, H is the one outcome, then H, H, T like this. This is my second outcome. So H, H, H or H, H, T, H, H, T, then H, T, H. So I have to traverse all the branches here. So H, T, H, then H, T, T. Okay, then T, H, H, T, H, H, T, H, T, then T, T, H, and last is T, T, T. And we know that this set is called sample space. So what is N of S here? N of S is the number of elements in my sample space. These are the total number of outcomes. So 8 possible outcomes are there. So there are 8 possible outcomes. Now after writing the sample space for this experiment, this random experiment, So this is very clear that this is a random experiment and the outcomes is written in front of you. Now my random variable here will be capital X, and I am interested in recording the number of heads appeared. So I'm recording how many times I have got head in all those three tosses. Okay, so X can take values like this: no head, okay, then only one head, then two heads, then all three heads. So this is very obvious to quantify it. How you are going to quantify? You are going to relate no head means 0 head, 1 head, 2 head and 3 head. This is my random variable. This X is called random variable because this variable is outcome. This is related to that random experiment. This is my random variable and it is going to take values either no head, either one head, two heads or three heads. Now this will look very familiar to you. So if I write X 0, 1, 2, 3, now you can see that this X is taking value from 0, directly jumping to 1, then after 1 it is taking 2. So this is my discrete random variable. This is my discrete random variable. Now I was saying that this will look very familiar to you. Why? Because now I want to count. I'm writing one more row below this. I'm going to count how many times there is no heads. So go back to the sample space and count how many times there is no head. So there is all heads, two heads, one head. So I don't want this row. There are two heads, one head, one head. So this is the outcome which is in your favor. Means you are searching for no heads. So this is in your favor. So there is only one outcome having no heads. Now let's count how many outcomes are there with one heads. You can see one head means this is what you want: 1, 2 and 3. So 3 outcomes is in your favor. Two heads. So how many times are there with two heads? 1, 2 and 3. Okay, so again 3. And three heads, there is only one outcome where you got all 3 heads. So 1. So just recall that this is the frequency of X. Okay, so I hope this is familiar to you all. This table, this will be similar to your frequency distribution. If you go back to the previous units, we had named this as frequency distribution, but we have to study probability distribution. Sorry. So to define probability distribution, I must attach one more row to this table, and obviously that row will be named as probability of X. So what I'm doing, I have attached one more row called probability of that random variable, and I am going to call that distribution as probability distribution. Now this has become a probability distribution. So you can have the analogy that a raw data, then frequency distribution, then group frequency distribution, then I had attached a probability column, and I'm going to call that table as probability distribution. This is how it looks like. Okay. So what is probability distribution? It's a distribution which gives the chances of occurrence of that random variable. So I'm writing the chances of occurrence of this random variable in that table. This is called probability distribution. Okay, so I have to write the probabilities in each cell. So this is called px. This is called px. So I have to, what is x here? This is p0, this is p1, this is p2, this is p3. Okay, so I have to do a calculation by using this formula that we had seen in the previous video. This one, the probability. We will find the corresponding probabilities and write there. Okay, so p x, or I'm going to write like this also. This is also written like this, p0. What is p0? This is the probability of, how to read this? This is the probability of getting what? No heads. This is the probability of getting no heads. Okay, so what's the formula for probability? N of A divided by N of S. What is the favorable outcome for this scenario? No heads. So there is only one favorable outcome where there is no head, and I have mentioned over here. This is that one favorable outcome. What is the total outcomes? 8. So it is 1 by 8. So it is 1 by 8. Sorry. So what I have to write? The probability of x equals 0 is 1 by 8. Okay, so this is 1 by 8. So here I have to write probability of x equals 1, means what is the probability of getting only one head? So 3 by 8. So I'm going to write here 3 by 8. Probability of x is equal to 2. See, I'm calculating probability of the random variables. Okay, so that's why I'm writing px2, or you can write simply p1, p2, p3. But you should know what is the how to read this. You should know that. Okay, so probability of, you can write p3 also. This is the probability of getting 3 heads. This is again 1 by 8. What about this probability of 3 by 8? So let me clear this and write it down. Only the probabilities. So the probabilities are 1 by 8, 3 by 8, 3 by 8 and 1 by 8. So I hope this is clear. This is called probability distribution, and this is how it looks. So you can do the same thing with different random experiments, like throwing a dice 2 times. So you do any experiment, you must find the sample space, or N of S. So throwing a dice 2 times, so it will be a very huge sample space. So on first throw I'll get 1, 2, 3 or 4 or 5 or 6. This is my first outcome. And on second throw irrespective of the outcomes on first throw, you have to throw the dice again. So on every throw you have to make this 1 2 3 4 5 and 6. So on every 1 2 3 4 5 and 6, 1 2 3 5 and 6, like this. So every outcome will have these branches. Four, 5 and 6. Sorry. So if you try to list all possible outcomes, you will see that it will be a huge list having 36 elements into it. So n of s here is 36. Let's say I want to define my random variable y as, so random variable here is the outcome on both throw should be, say, 7, should be 7. So the outcome on the both throw, it should sum up to 7. So you have to think which outcome is going to be give you the sum of 7. Okay, so like 3 and 4. So the sum of this is going to give you 7. Then 4 and 3 also. Okay, then 1 and 6, then 6 comma 1. So this one is the outcome on first throw, and this 6 is on second throw. So you can see that this 1 and this 6 is my favorable outcome from here. Then 2 added with 5 is 7, then 3 added with 4, then 4 added with 3, then 5 and 2, 5 and 2. So this is 5 and 2, then 6 and 1, 6 and this is 1. So on every branch you have one outcome. Okay, so on every branch you have one single favorable outcome. So like this you have 6 favorable outcome. You can see 1 2 3 4 5 and 6. Got it? So n of a is 6 and total outcome is 36. So what is the yes, so what is your random variable? Your random variable is y, and the probability connected with that random variable is probability of a is 6 by 36, 1 by 6. So this is the probability connected with this random variable, and if you write these information in a tabular form, that is called probability distribution. So this is all about how probability distribution looks. So you just need to add one more column which is connected with your random variable, and it is informing you about its chances of occurrence. Okay, now let me end this video by mentioning the types of probability distribution. So in this types of probability distribution, we have binomial, probability distribution, second we have Poisson probability distribution. Third is normal probability distribution. So these are some of the probability distribution I am listing down here. And chi-square probability distribution. There are so many in the list, so this is the 4 probability distribution that you will find very easily in any book or websites. You can Google it. So we have to study first 2, binomial distribution and Poisson distribution. So in next video I'll continue with binomial and Poisson distribution. So that's all for this video. Thank you everyone.